Hello, Year 10s. Today we're going to look at how to find the intersections of a line and a quadratic graph when they're both plotted on the Cartesian plane. Now, as you can perhaps visualize, when you plot a quadratic and a line on the plane, one of three things can happen. Either it can miss altogether, it can cut twice, the line goes through the quadratic twice, or it can just touch. Note if it's just touching, then this line, the linear equation, is called a tangent to the quadratic. That there is a tangent to the quadratic. Now you might be looking at this and thinking, well, that's suspiciously similar to what the quadratic equation can do to the x-axis. Recalling that we could either miss the x-axis, touch the x-axis, or cross the x-axis twice. And the good news is these are incredibly related, because if you're given this example here of a quadratic and a linear, what you can say is if they're going to intersect, then the y values must be equal. And we can substitute this y value for what we know the other y value is equal to. So that I can then write 3x plus 4 is equal to x squared take 5x plus 7. Now, for solving anything like this, we want 0 one side, everything else on the other. So 0 equals x squared take 8x plus 3. Alright. Now, the reason why the nature of our solutions is so similar, having three options, miss, touch, cross, is because when we solve between a quadratic and a linear, we're always going to end up with a resultant quadratic. And if we look at this thing's discriminant quickly, b squared take 4ac, we have 64 take 4 lots of 1 take times 3, so it is 64 take 12 is equal to 52. Good news for us is that's positive. So because we know it's positive, we know that this is going to have two real solutions, as in this linear will cross this quadratic twice. Now, if we look at this, we can see pretty early on that this can't be factorized using normal methods, therefore our method of solution must be quadratic formula. You could complete square, but that's a pain in the backside. Let's use quadratic formula. X equals minus b plus or minus the square root of b squared take 4ac over 2a. X equals minus b, so that's 8, plus or minus. Now, I already found what the discriminant is, so that's going to be root 52 over 2a. Reason I found discriminant first is because if it turned out to be negative, then I'd certainly gone quadratic formula. If it turned out to be a squared number, like 64 or 9, I would have tried to factorize. The discriminant's a good indication of where to go. Alright, now we want to simplify a bit. So this is the same as x equals 4 plus or minus, now root 52. Does 4 go into it? Yes. How many times does 4 go into it? 13 times. 4 13s, root 52. Yeah, sounds good. So that's the same as root 4 times root 13 over 2. Now, good news for us, root 4 is in fact 2 over 2, so that goes, leaving us just with root 13. So our answers are x is equal to 4 plus or minus root 13. Now remember, that is actually not the point of intersection, that's just the x-coordinates of the point of intersection. So we're well over halfway there, but this bit gets a little ugly, because to find the points of intersection, we need the y-coordinates also. The y-coordinates also would be found by substituting that value of x into either equation. Good news is we can choose which one we want to use, and let's choose the linear because it's a lot easier to work with. So our two solutions are going to be y equals, now we had what, 3x plus 4 was it? Okay. One note. Good. 3x plus 4. So we know the value of x now. It's 3 lots of 4 plus root 13 plus 4. Y equals 12 plus 3 root 13 plus 12. So therefore y is equal to 24 plus 3 root 13. Or the other coordinate, the other y value would be y is equal to 3 lots of 4 take root 13 plus 4, meaning y is equal to 24 take 3 root 13. Our 2 points of intersection, therefore, are going to be 4 plus root 13, comma, 24 plus 3 root 13, and 4 take root 13, comma, 24 take 3 root 13. Alright, now, if we want to check our solutions, we can put those equations in the calculator. Control I, escape, escape, Control I, new graph. X squared take 5x plus 7. One quadratic, the other one is 3x plus 4. So press tab to insert a new one. We can go 3x plus 4. Alright, once again, we can't see both intersections, so let's change this to about 30 and see if that helps. Yes, it helps enormously. Now, our 2 intersection points, there and there, we find them going menu, analyze graph, intersection, and we want to go between there and there. Gets us 1, menu, analyze graph, intersection. And remember, instead of clicking using the mouse, 6, you can just press the numbers 6, 4. And then we want to go below, above. Now, how do we know this is right or not? For example, how do we know what 0.394 actually is? My bet would be 0.394 is what you get when you put 4 minus root 13 into the calculator. Alright, so if the question asks you to find the roots to 2 decimal places, the intersections to 2 decimal places, calculator is a good way to go, because it gets you there to a couple of decimal places. However, if you're asked to find the exact points of intersection, when it says exact, it means in square root form. So it will be in the form we're seeing here. Alright, in your OneNote, can you please find the intersections of those 2 graphs? And yes, I know they're not both linears or one quadratic, one linear like I both just showed you. Instead, they're 2 quadratics. So if you think about it, there's still 3 different options that can happen. There's a miss, a touch, and a cross. I'll give you a hint. This one's a cross. It means real solutions. Thank you very much, and I'll see you next lesson.